Hello, so today we're going to discuss the non-contact forces. Now, usually, non-contact forces are the forces that doesn't require any contact. Okay, so in case this is, for example, if two surfaces are touching, then it's contact. But if an object has an effect to attract or repel another object which is far away, then we can say that it's non-contact force. Like for example, we are all attached where? We are all pulled where? Down, right? We're not pulled up. If we're pulled up, then we can, for example, fly. But we are all pulled to the ground by a force which is non-contact, doesn't touch us, which is called gravity, for example. Same thing for the magnets. So let's say there is a magnet, another magnet, and it's a bit far from each other. When you try to put it beside each other, then you can notice that they either attract or repel. Okay, but they don't touch. So this is what I'm talking about. So it doesn't require any contact with the surface. It can act by a distance, and it's eventually a force. So we are all pulled to the ground by a force that we can't see it. It's not touching us, but we are pulled, right, by the gravitational force, for example. Same thing for example, the balloon. The balloon usually, if you rub it into your head, then electric charges will be transferred. When electric charges is transferred, then the balloon will maybe have a positive charge, and your head a negative charge. So if you place the balloon up your head in a distance, not in contact, so you can notice that the hair will be attracted to the balloon. This indicates that it can act by a distance and it's a non-contact force. So electric force is also a non-contact force. So we have now three: weight, and electric force, and magnetic force. Now, what if, girls, look at this? So this is a tissue, okay? Nothing, I'm just touching the tissue and I leave it. Okay, it's pulled, it's attracted. If it's not attracted, if there's no force is made upon this, then it will be at rest in the hanged, yani in the air. But since I leave it, no forces, so there is a force which is applied to any object that has a mass, which is called gravitational force, the force of a gravity. If it's by Earth, it's called weight. If it's between an object and the other, for example, it's called gravitational force between objects. Okay, so in case object with earth, weight, object with object في gravity أكيد, because both are in their places. If there's no gravitational force attraction between them, then we can't handle anything, we can't catch anything. Okay, so that's why it's so important to understand that there is a magnetic force or a electric force or a gravitational force applied. Okay, all objects are attracted to each other by a gravitational force. Of course, any object that has a mass, any object has weight. The gravity is applied. The earth will pull this object to the ground. And you all know that the SI unit of mass is kilograms. Now I just need you to focus on this thing. So whenever two objects, let's say this object and this object, whenever these two objects mass increase, okay, and let's say I replace these two objects by a bigger object like this, okay? Bigger objects means that the mass increase. So the gravitational force between the bigger objects also increase. While, what about the distance? Look at the distance. These two objects, if they're close to each other, then the gravitational force will be